Hello friends, in today's question, a block 0.5 kg slides from a point A, as in figure, on a horizontal track with initial speed of 3 meter per second towards a weightless horizontal spring of length 1 meter and force constant of 2 Newton per meter. The part AB of the track is frictionless and part BC has a coefficient of static and kinetic friction as 0.22 and 0.2 respectively. If the distance AB and BD are 2 meter and 2.14 meter respectively, find the total distance through which the block moves before it comes to rest completely. Take G as 10. So this is the figure. We have block at A, and between A and B there is no friction, and this distance is given as 2 meter, and we have a BD, or rather we can say BC, that is consisting of friction, and the length of BD is given as 2.14 meter. So we have to find out the total distance through which the block moves before it comes to rest. So let us consider for the first part, when the floor is frictionless. So it means there is no opposing force for it. Therefore, we can find out its the kinetic energy between A and B. So we can say for AB, which is frictionless, because of this frictionless, from here we can say block moves the distance AB without any loss. Any loss in energy. Therefore, its initial velocity is given as 3 meter per second. So we can find out its kinetic energy. From here we can say its kinetic energy is equal to half mv square, which could half mass is given as 0.5 and velocity is given as 3. So from here we can say its kinetic energy is given, will be coming as 2.25 joules. So this will be its kinetic energy up till point B. Now we come to the second part. The distance traveled is BD, which is consisting of friction. So we can say for BD, which consists of floor is friction or having friction. So we can find out the work done against the friction. So basically it means we are going to find out the amount of energy that is being consumed in traveling the distance from B to D. So we can say work done against the friction so which will be equal to the kinetic friction, mass G, and distance traveled D. Substitute the values. So you can say work done will be equal to kinetic is given as 0.2, mass is 0.5, G is supposed to be 10, and this is 2.14. So we can say the work done will be coming as 2.14 joules. So it means this is nothing but the loss of the kinetic energy. this we can say is the loss of the energy. Therefore, we can find out the kinetic energy at point D. Thus, the kinetic energy at point D will be equal to 2.25 minus 2.14, and this will be coming as 0.11 joules. So this is the kinetic energy which is at point D. Now at point D, it is going to strike the spring, and the spring is going to compress. So as we say, let the spring be compressed by X. Let the spring is compressed by X. Therefore, you can say now this compression, or we can say the amount of energy inside the spring will be divided into two parts. One will be because of this potential energy, and another will be in the form of the kinetic energy. Okay. So we can write the equation that kinetic energy at D is equal to potential energy of the spring plus kinetic energy of the spring. So kinetic energy at D is given as 0.11. So potential energy of spring will be equal to mu into m, g and x, which is the compression, plus it will be coming as half k x square. We substitute the values. We can say that 0.11 is equal to 0.2, mass is 0.5, g is 10 multiplied by x plus half. Coefficient k is given as 2 multiplied by x square. This will be giving us a quadratic equation which we can write as x square plus x minus 0.11 is equal to 0. And from here we can say one of the values will be coming as x is equal to 0.1 meter. So the spring will be compressed by 0.1 meter. Now let us find out the force exerted by the compressed spring, and then we are going to make a comparison between the force as well as the compressed force. Okay, so you can say compressed force exerted by the spring, and the formula is F is equal to kx. So k is our 2, this is 0.1, so this is coming as 0.2 Newton. And next we can find out the value of the limiting friction between the block and the track. The value of limiting friction between block and track. Let us call that as FL, which will be equal to mu s mg. So we can find that value of limiting friction FL will be becoming equal to 0.22. Mass is given as 2, G is 10, sorry, 0.5. So we get FL as 1.1 Newton. So now what is going to happen, that as spring is compressed, so spring has a tendency to come into its original position, but the friction will try to prevent the block. Okay. So under this condition, you can say the spring is compressed something like this. So spring will try to expand in this direction with the force F, and in opposite direction there will be a value of the limiting friction which will try to prevent this spring from moving back along the block. And from the comparison, you can see that the value of limiting friction is greater than the compressed force F, but FL is greater than F. So basically it means that this block will not move. From here we can say block will not move so at the block, as the block will not move, the distance traveled by the block along the spring will be equal to x. You can say thus the distance traveled by the block along with spring will equal to x, and that value of x is given as 0.1 meter. Therefore, the total distance traveled total distance traveled by block, okay, it started from point A, and then it is B, and then it is D, and this is our x. So this is x, this is 2, and this is our 2.4. So this is our total distance. This will be equal to AB plus BD and plus x. So if we substitute the value, we get 2 plus 2.14 plus 0.1. Therefore, we get the total distance will be coming equal to as 4.24 meter. Okay. So this completes the question. Thank you.